Welcome to The Explainer. Today, we're going to get into the tech that's finally teaching AI how to stop, well, making stuff up and start actually looking things up. So let's start with a problem that I'm sure we've all run into. You ask your AI assistant a question, and what you get back is this beautifully written, incredibly confident, and completely wrong answer. Sound familiar? In the AI world, this isn't really seen as a bug. It's actually a well-known issue called hallucination. And honestly, it's one of the single biggest hurdles we have to overcome to make these tools truly reliable. So how do we fix this? Well, that's what we're here to break down. We're going to talk about when AI confidently lies, then we'll get into the solution, something called RAG, which is kind of like an open book exam for AI. We'll look at how it maps meaning with vectors, prepare that knowledge with something called chunking, and then store it all in a semantic library. And finally, we'll touch on whether you should build that library locally or use a hosted one. All right, let's jump in. All right, so the solution, and it's a really elegant one, is a technique called retrieval augmented generation. We just call it RAG for short. Now, the best way to think about RAG is this. It's like giving the AI an open book exam, instead of forcing it to rely only on what it memorized during its training. Okay, so this workflow you're seeing here, it's a total game changer. We start by breaking down our documents into these little chunks. Then we convert those chunks into numbers, we'll get to that in a sec, and store them. Now, when you ask a question, the system first searches for the most relevant chunks, and then, and this is the magic part, it stuffs those relevant facts right into the prompt it sends to the AI. See what's happening? We're not retraining the entire model, which is crazy expensive. We're just giving it a little cheat sheet right at the perfect moment. Okay, but that brings up a huge question, right? How in the world does the AI know which information is relevant? How can it search for a concept, an idea, instead of just matching keywords? Well, the secret sauce here is this amazing mathematical concept called embeddings. So what an embedding does is it translates words, sentences, you name it, into a purely mathematical format. It turns it into a long list of numbers, which we call a vector. And you can think of that vector as a coordinate, like a precise set of GPS coordinates for an idea on this giant abstract map of meaning. And this image here does a great job of showing what that map of meaning, or what's technically called latent space, looks like. Concepts like mouse and rat, they're plotted super close to each other. Makes sense, right? But something totally unrelated, like airplane, is way out in a different part of the map. This is how the AI finds related stuff. It just looks for the points that are closest together. It's all about distance. Now, to really capture all the nuance of human language, these maps aren't just 2D or 3D. They are way more complex. Get this, a popular model like OpenAI's text embedding Auther 002 uses 1,536 dimensions to plot the location of just a single idea. It's kind of mind-bending, I know. Each of those dimensions represents some abstract feature of the text, which lets the AI grasp really subtle relationships. It's a space we literally can't picture, but it's exactly what gives the AI such a deep understanding of language. Okay, so before we can start creating all these powerful vector coordinates, we've got to prepare our documents. I mean, you can't just throw an entire book at an embedding model and hope for the best, right? It just doesn't work that way. We need to break the information down into smaller pieces first. And this process, logically enough, is called chunking. Now, chunking is absolutely crucial. Why? Because smaller, more focused chunks of text create much more precise and useful coordinates on our map of meaning. Think about it. If your chunk is too big, say a whole chapter, its meaning gets all washed out and generic. It's not very useful for finding specific answers. And how you actually do the chunking involves some real trade-offs. As you can see here, you could split by sentence, which is great for keeping the context intact. Or maybe you split by paragraph. But if you're just going for raw speed and efficiency, you could split by a fixed length, say every 500 characters. There's no single best way. It really just depends on what you're trying to build. Now here's a really clever trick. A key technique, no matter how you split things up, is to create a little bit of overlap between your chunks. This ensures that you don't accidentally lose the context of an idea that gets split right down the middle, where it starts at the end of one chunk and finishes in the next. It really is like a little safety net for preserving meaning. Okay, let's recap. We've got our text broken down into neat little chunks. Each of those chunks now has a vector coordinate on our map of meaning. So, where do we put all this stuff? We need a special kind of library, one that's designed from the ground up to search by meaning, not just by keywords. And that's exactly what a vector database is for. This is not your typical database that's just looking for exact keyword matches. Nope. This is a library organized purely by semantic meaning. It makes searching for similar concepts incredibly fast. It's the kind of database where you can literally do math with words, like asking for king minus man plus woman, and it'll point you straight to queen. Pretty cool, right? So now we know what a vector database is, and the obvious next question is, where do you get one? If you're a developer building one of these systems, you've basically got two main options. You can run it yourself using open source tools, or you can use a hosted service in the cloud. Let's take a quick look at the pros and cons. On one side, you've got something like FAISS, which is an open source library from Meta. This is awesome because you can run it right on your own machine. That gives you full control, full privacy, perfect for when you're just starting out or working with really sensitive data. On the other side, you've got hosted services like Pinecone. With them, you don't have to worry about all the complicated stuff like scaling and managing the database. They handle it all for you. That's a huge plus when you're building a big application for lots of users. So at the end of the day, this whole system, RAG plus vector databases, is what's making AI assistants so much more useful in the real world. It's what lets you do incredible things like chat with your PDFs. It's how a chatbot can have a memory of conversations you had thousands of messages ago. And it's the engine behind those spooky good recommendation systems that find stuff you'll actually love, not just things with the same keyword. And this brings us to a final and kind of mind-bending thought. What we're doing here isn't just building a better fact checker. We're essentially giving AI an external brain. We're letting it access and piece together information on demand. And that really starts to blur the line between just recalling information and actually understanding it. It kind of makes you wonder, what does it even mean to know something anymore?